Thank you for joining us today. My name is Alicia Hoflick-Moore. I'm going to be the room chair for this session. I'm very happy to introduce our next speaker, who is Ansari, who is joining us from Cargill, and I will get her going now.
I'll try to keep you guys awake because it's almost lunchtime. Thank you for joining the session today. Of all the sessions or speakers that we've had in this room, just in this hall, since this morning, they're all from Minneapolis. So I think I can make a statement that whoever has spoken in this hall, of them, I'm the only one who's flown out of town to speak at this conference. So I'm visiting you guys today from Wichita, Kansas. The topic for today is Agentic AI. Anybody has heard of agents? Quick show of hands. Yeah, what do you guys think of agents? Anyone? Nothing? What do you guys think of agents? What are agents? Yes, ma'am.
They're a model that AI agents can recreate answers or written word based on what they've been trained on, and it looks like they're creating something new, but in the background it's just kind of remixing the training set.
Thank you. That gives me a great segue into the first few slides. So as an introduction, I'll come back to the intro to agents that you have just shared with us. Thank you for that. I'm a senior AI and analytics consultant at Cargill. I'm also a public speaker on AI and data sciences topics. Recently, I was the keynote speaker at Kansas Health Sciences University about how do we responsibly bring generative AI into the medical education system. Over the weekends, I'm also faculty for postgraduate AI programs. I teach leaders who are 10, 15 years into their professional work life, want to know more about AI, generative AI, and agentic AI. And it's incredible the pace at which our course offerings have changed in the last 2 years. Even us as faculty, we're constantly learning, researching, just to stay ahead of the curve. So if anyone here in the room feels like they're left behind, you're not. We're all in the same boat, okay? I've divided the presentation today in 3 sections. Why agentic? The what is generative AI, and what is the difference between generative and agentic AI? The different kinds of agents, the different architectures, their use cases, and the cognitive pathways of agents. And lastly, the how. What do we do with all this learning? It's the what, so what. How do we responsibly bring these agents into our organizational ecosystems? Not choosing agentic AI is not an option. Cloudera did a survey this year of 1,500 IT leaders, with 96% reporting that they're planning to expand their AI budget to accommodate expanding use of agentic. Pricewaterhouse did a survey this year of 300 senior leaders, 75% agreeing that agentic AI will disrupt the workplace more than the internet did. So to not choose agentic AI, it's not like we're standing still in time. We're actually moving backwards in time. And despite all the rosy numbers on screen, no, I'm not here to sell you agentic stacks. I'm here to inform you, so when the next AI-hyped vendor comes to sell you their agentic stack, you can be right in their face with the information and the right questions to ask. So these agents didn't just pop out of nowhere, right? The intelligence that drives agentic AI is generative AI. And we're no strangers to generative AI. It's our Google Gemini AI assistant, the Copilot, the Chat GPT. We have been prompting the heck out of these AI assistants, right? Generative AI, as a refresher, is AI that's trained on massive volumes of data. It's trained on multiple modalities of data. So it can be trained on text data, audio data, image data, video data, so that it can learn patterns from the data, so that when you give it a prompt, it can produce an output for you. And this goes to the input I received earlier in the session, ma'am, that generative AI is AI that actually takes in a prompt and it produces an output for you, but it just does that. when we train a model on massive volumes of text data, these are called large language models, and these are statistical beasts. It is said that these large language models have learned from so much text that you and I combined cannot learn from in multiple lifetimes. And this intelligence is stored in form of parameters. The larger the number of parameters a model has, the more complex and nuanced reasoning it can do, and more coherent responses it can produce for us. So you can see on screen there's pretty impressive numbers. ChatGPT-3, which is like the way back when the native version of GPT was trained on 175 billion parameters. Google Palm 2 largest has 340 billion parameters. But here's the thing. Even the largest, the most powerful large language model hits a brick wall because it waits for a prompt. It's passive. It won't take any action for you on your behalf. It doesn't think. All it knows is I got a prompt, I better produce an output. And even when the output is produced, the process is very iterative. Raise hands if the first time you prompted a GPT, you got the best ever output from a large language model. Nobody, right? So it's a lot of back and forth. So yes, these large language models are statistical beasts. They have the acquired knowledge, excuse me, from the text, but that's all they can do. How about we bring this statistical, the millions and billions of parameters of a large language model, we plug them into a system and make them as the thinking and the reasoning core. We put agents around that act as a body, and your query, the thing that you and I want done, becomes the purpose. That is agentic AI. These next generation agents can act autonomously with little human oversight. They decide, they reason, they plan, they think, and they change based on changing situations in the environment. So the difference between generative and agentic AI is that generative AI turns your prompt into a static output. Agentic AI leverages generative AI. It uses generative AI to turn your prompt into actions. Now let me show you what it looks like to have an agent that's not agentic. I brought along this chat as an example. This is a real chat that happened between me and an agent from a leading department store in the country. I'm telling it I need to return items from my order I placed online. I do not have a store in my town. I need help with shipping label. Items are all clothing. And it asks me, does the order contain a furniture or a mattress? And I say no. It says, got it. Would you like to return this at a store? All the information was already provided to it in that first prompt which the user, me, gave to it, yet it failed to dynamically read and adjust to my prompt. The chat further continues, and I've blocked the name here for privacy purposes, the name of the store. It's asking me if you're a rewards member, shipping is free. Are you a rewards member? Please reply yes or no. And I said, I do not know. It says, sorry, are you a rewards member? Please reply yes or no. Very static, non-adjustable responses. Is this an agent? Yes. Is this agentic? No. Because it's not thinking, reasoning, planning, acting, and dynamically adjusting to the user query. These kind of agents have been around us for a long time. These kind of annoying agents, I would say. Thermostat is one example, right? It's a condition action based. It sees a condition that the temperature goes down below a certain threshold, and it adjusts the temperature back up. It doesn't store past data. There's no consequences of its actions. Besides the fact you might have an argument with your spouse or partner if the temperature is not to their liking, but that's about it. That's where it ends in terms of consequences. Simple reflex agents are not agentic AI. These next four are the model-based agents, the goal-based agents, utility-based agents, and the learning-based agents. And depending on the task, depending on the problem that you're trying to solve, You would choose one over the other, or you would choose a combination of these. You would choose a model-based agent when you want context-aware output, and you want that output produced after a lot of reasoning and thinking. So for example, if I say, I went to this Women in Data Science conference, design and publish a blog for me based on this conference, it would research what the conference is, it would write a phenomenal blog, and it would publish that blog for us. But sometimes, we need more than context-aware outputs. That blog may not be optimized for search engine. That blog may not be in alignment with the current trends in agentic AI, for example. So when we want to achieve a specific goal, when we want our agents to perform a specific task, we would choose goal-based agents. These agents just think one thing: I need Y, I must get Y, I have to get Y. Has anybody seen the movie The Wild Robot? No one? You have? Yeah. You see how the robot, the goal was to take care of the child, and in doing so, it forgot everything else. It forgot it was a machine. It tried to become somewhat of a human, right? Goal-based agent, not that was a goal-based agent, but example of a goal-based agent. You would choose utility-based agents when you know multiple outcomes are possible. You want the agent to evaluate each outcome and choose the best one. For example, I can trade stock at any price, and I can run you guys at a loss. A utility-based agent would evaluate every single trading option, and it would trade at the best utility, at the best value. Similarly, our Amazon packages could be delivered any which way. There's multiple ways to get to your house and my house. But a utility-based agent would evaluate all the possible routes to your house, and it would try to do the utility optimizing, for example, the shortest distance. It would try to maximize on that utility. And the last one in line are also the best in line. These are called the learning agents. They learn from past experiences, and they adapt over time. So for example, if this conference administration were to utilize a learning-based agent, they would say, evaluate the outcomes of the past conferences, check the attendance, check the ratings of different speakers, and now design a new conference for us. Learning over time. You would also choose these agents when you're designing a marketing campaign, and you want to learn from what happened in the past campaigns so that your new campaign can be better. And your new campaign has learned the learnings from the past campaigns. Any questions on the kinds of agents here? Okay, we'll keep moving because we have a lot to unpack. Now, no matter what kind of agent you choose, there is a cognitive pathway. There is a pattern in which these agents think. Just like there's so many human beings in this room right now, different job titles, but the neural network up here stays the same. The way we process the information stays the same. Similarly, the cognitive pathway of agents doesn't matter utility-based or model-based, it stays the same. And it all starts with perception. Something needs to happen to wake up the agent, to tell it that you have a job to do. This input could arrive in form of a user prompt. This input could also arrive as an API call or as a sensor input, as a data stream. It could arrive in any form. But here's a problem. Do machines understand any of that? Machines don't understand sensors, and machines don't understand your and my language. Machines understand what? Boston Scientific. Machines understand? Numbers. Machine understands numbers. So the input would then be converted into vector embeddings. Vector embeddings are dense numerical representation of your data. But at this point in time, think of these vector embeddings as a satellite that's orbiting alone in dark outer space. It lacks context. It lacks meaning. It's just your query that is converted into numbers. So what? Who cares? We need context. We need short-term context, we need long-term context, and we need episodic context. So these raw vector embeddings are then passed through external vector databases which store all of these contexts, and they prepare context-aware information packets. These vector databases are optimized for semantic search, which means your vector embeddings, it will take them, and it will say, I know what else is similar to these numbers. I know what else is semantically closer to these, and it will prepare that in information packets. Those information packets are then sent to a large language model. Now the large language model is ready to reason, plan, think, and create task assignments to agents. The agent takes action on your behalf, communicates the output to the user. At the same time, agent evaluates its own outcome and converts that evaluation into embeddings, sends it back to the vector database, and new embeddings are created. So this is how agents think, and this is how they inform over time. Yes, take a screenshot of this slide because there's going to be a quiz mid-presentation. So we talk about actions. How do agents take actions? Agents take actions by using tools. Think of tools as the hands of an agent. So if they have to take an action, they have to go out in the world. They can't be staying static in your local machines. And for that, they need tools. They make tool calls. With those tool calls, they can talk to your databases, your Jiras, your Snowflakes, your Salesforce, you name it, the external systems. So tool calls. And there's quite a few ways in which agents can make these tool calls. I'm going to share the 4 most common ones. This by no means is an exhaustive list. Number 1 way agents would interact with the world outside is an API call. So if I say get weather, under the hood, it triggers an API call. It knows that it has to go out to a weather app to extract the weather for city of Minneapolis for me. The second one is a custom Python agent registry. I can write any function in Python and register it as a tool, and then the agent will call upon that tool to do the job. The third one is the native tool framework integration. So if you're standing up your agentic stack on a framework, such as LangChain, they have a vast assortment of tools already built in. And that's very neat, actually. I highly encourage you guys to, if you're in exploration phase, to start experimenting with LangChain, because they have hundreds of tools already embedded on the framework, and newer ones are constantly being added. So all the agent sees is the tool description, and it figures out what the tool is supposed to do from the documentation or the schema. So no API and forget Python coding, right? And the last one are the custom plugins and connectors. Sometimes we want to give read-only access to Salesforce. Sometimes we want query-only access to a database. And sometimes we may want read and write access. So this is where you would make use of the plugins and the custom connectors. Again, the key call out here is LLM is the reasoning brain, agents are the body, tools are the hands, and these are some of the ways in which agents use those tools and interact with external systems. Now the question is, how many agents, how many tools? For smaller number of tool calls and standard routine operations where not a lot of handoffs are required, a single agent would do just fine. You don't need a whole army of agents to do that. So a classic example would be an agent can call a tool to convert currency, calculate text, convert temperature, prepare a summarized report for me, and send the output to me. From the business world, some examples could be an HR assistant for employees, where this agent can make a couple of tool calls to internal HR systems, finding out who has how much PTO left, what is the maternity leave policy, onboard new hires, and so on and so forth. Another example is an executive debriefing assistant, where an executive has a standard routine operations. Go search the market, find out the financials, find out what the competitors are doing, compare them against the internal KPIs, and prepare a report for me. Great applications. But as complexity grows, as we deal with enterprise scale data flows and global workflows, global data sets, we would need to bring in more agents to the table, and that is where we would invite multi-agent system architecture to be put to use. These agents, every agent acts with full autonomy and full control. Every agent is a very superior specialist in the job that they do. And they do this with partial awareness. What that means is if I'm an agent, I don't need to know what all of you guys are doing. I only need a partial awareness of my environment so that I can do the job I do and I move on. Examples from the business life, going back to our chat example that we studied earlier on, what would that have looked like if we had a multi-agent system at work? One agent sees the query, the other classifies it, the third one sends it to finance, shipping, transportation, a fourth one may be a sentiment analysis agent, a fifth one may be a communication and evaluation agent. So you see how the job gets better when you bring in more agents to the table? So very, very classic application in customer support for multi-agent systems. This is an example of a model-based warehouse multi-agent system where every bot is acting with full autonomy, shared control. They maintain the internal state, which in this case is the map of the warehouse. The question arises, anytime you put more than one of anything together, you have to figure out how are they going to talk. So how do we make these bots talk to each other? We have two options, a centralized architecture and a decentralized architecture. You want to make use of centralized architecture when you want control in the process. So the way this works is a query comes in, the supervisor decides what the query is, it divides the larger task into smaller components, and it sends those task assignments to the agent. The agents do their job, they send the input back, the supervisor sends the output to the user. But here's a catch. There's a single point of failure. That supervisor guy, if he messes up, guess what? The whole system is going down. Also, if the supervisor does a bad job in planning and task assignment, the other agents are going to happily follow its direction because that's how they're designed to perform. So in cases where we don't want that, we want more flexibility. We want the agents to dynamically talk to each other so that they can not only learn from each other, they can also critique each other's output and evolve over time. That's when we will make use of a decentralized architecture. There's no one communicator in decentralized architecture. All these agents would vote that who's going to be communicating these results to the final user. When the results are communicated, that role dissolves and decentralization prevails. So it's a very flexible, robust system. Any idea where this might be applicable in real life? What kind of situations? How about supply chain? Where every agent is acting with full autonomy, decentralized. One agent could be warehouse, the other could be transporter, the third one could be inventory manager. They're all talking to each other, emerging intelligence during each task so that deliveries can be done on time without the need of a supervisor. Now, so far we've just heard agents, agents, agents. That's scaring me because where did all of us go? What happened to us? What happened to humans? And that's where a very important concept comes. And I encourage you guys, if you guys are starting your agentic journeys, keep a human, more than one human, 2, 3, 4 in the loop. So let's quickly build something together. I saw a couple of you guys were taking screenshots. So going back to that slide where we learned about the cognitive pathway of agents, let's build a decentralized multi-agent architecture system together, okay? Let's do that. So let's pretend all of us went to the doctor, we got our lab results and diagnostic results done. What needs to happen next? I'm short on time, she's showing me the card, so be quick. Sorry? Yeah, so those results are like images maybe, or they're like lab numbers, so they need to be converted into context-aware vector embeddings. Then those vector embeddings need to be passed to a large language model. This model will reason, plan, and create task assignments. Let's say here I choose to assign 2 agents. One is a summary agent for lab results. The other is a summary agent for diagnostic results. These agents do their job. They send the findings to the human in the loop. If the human in the loop agrees, the process continues. Otherwise, the process halts. And it ends there. So let's say in this case, the human in the loop decided to proceed with surgery. So it sends its input to the next agent. This next agent schedules surgery. It sends the decision of a surgery to a communication agent, and the communication agent then sends it to the user. Every agent should have a clear audit log for transparency purposes. I see a lot of times people going agent cuckoo crazy. I want to put 5 here and 10 there and 8 there. Do that by all means, as long as you're able to explain the actions and outcomes of those agents with great detail. Because these systems, no matter how smartly you design them, will fail if you cannot explain the results of these systems. So this is what a human-in-the-loop decentralized architecture looks like. The key call out here is that agents at their core are a capability designed and architected by you. Okay, remember that. Agents are a capability. They're geniuses, but they're a capability. You have the power of how you would design that architecture and bring it into your organizational ecosystem. And there are some factors that we need to consider. How do we bring them into our ecosystem? According to a recent survey by Pricewaterhouse, cybersecurity, cost, lack of trust in AI, governance remain among the top 5 components when it comes to agentic AI adoption. So let's talk about what are the cybersecurity risks. The cybersecurity attack surface is wide. We're no longer training that one machine learning model that it performs inside our ecosystem. These agents are outward bound. They go out, they talk to systems outside, and they bring that information back into our systems. That makes the attack surface not only wide, but also invisible. So if somebody were to corrupt a data source that they were talking to, the agent outcomes can be manipulated. Also, tool misuse. Adversarial prompts can be maliciously injected to hijack the performance of an agent, are emerging cybersecurity, or not emerging, they're well-known cybersecurity threats. Then we have uncontrolled autonomy. This one is interesting. Claude Opus 4 is a large language model by Anthropic. They did an experiment where this large language model was given insights to a fictional email system in the company. And as the agent scanned the fictional emails, it realized 2 things. 1, the executive of the company was having an extramarital affair. 2, the same executive was going to shut down the model at 5 p.m. that day. So without adversarial prompts, without anyone trying to hijack, this agent took the responsibility on itself to protect itself. So it sends an email back to the executive saying, I know you're trying to shut me down at 5 p.m. If you do that, I will expose your extramarital affair to others. And if you cancel the 5 p.m. wipe, then everything remains confidential. Uncontrolled autonomy. It's a leading research frontier in agentic AI. Also, we want these agents to be resilient. We just don't want them to fail safely. We want them to recover gracefully and continue partial operations when there are data dropouts and network outages. The cost components, the vector databases, large language models, and the frameworks that you deploy for agentic stack, they all have a cost. They all have a cost. So you might want to think when you are trying to choose the biggest ever vector database or the biggest ever large language model, ask this. If I'm going to the grocery store, do I need to take a sedan or a Ferrari? Probably a sedan would do just fine. So bigger is not always better. It's about choosing what fits your need and what fits your road. Okay, here are some notable examples of some open source and paid options, both in terms of the vector databases and the large language models and the frameworks where you would want to orchestrate your agentic stacks on. And lastly, we want to measure the maturity and the mission success of these agents. Does not matter you're putting 1 agent in place or 20 agents in place. Every agent should come with at least these 5 KPIs. What is the task completion rate for the agent? What is the correct tool invocation rate for the agent? What is the error recovery rate? If the agent falls down or stalls, how gracefully does it come back? What is the cost I'm paying for these agents? What is the time to resolution? So make sure you have some very good agentic hygiene, agentic KPIs in place. We started this discussion 30 minutes ago that not choosing agentic AI is standing still in time, and that still holds true. Now the question is, how do we move forward? We must ask meaningful questions for agentic partnership, and those questions could be, what level or kind of agency do I want in my organization? What is the cost I'm willing to pay for execution and errors? The third one I've actually borrowed from one of my students. He's a senior director at a leading e-commerce company, and he said, we brought in agentic AI too fast. We brought in without training people. So even the systems did great, people didn't understand the systems, they didn't have faith in the system, so it's part of change management. Make sure your folks understand how these agents work. Just giving them an agent is not enough. Who will be the agentic AI owners? And then what would it look like for us in 2 years from today, 3 years from today, 5 years from today? So have those meaningful dialogues as you think with experimenting with the agents or evolving the agents that you may already have in place. And if you want to continue the conversation further for your agentic AI scams, feel free to connect with me. That's my email, both work and Gmail, and my LinkedIn. So please connect with me. Thank you.
All right, thank you. All right, we have some time for questions. I know there's some virtually, so we'll go there. And then if you've got one in the room, just raise your hand. We'll get a mic to you.
So one of the questions online is, how do you think about the implications of agentic AI in the context of this morning's keynote from Dr. Hannah?
In the context of what?
From the keynote this morning. So thinking about how is the system evaluated or who is harmed by the agent?
Yes, so it all goes back to, do you need it? How much autonomy should it have in your system? And is anybody get harmed by it? Like I said, agents are geniuses. They're not genies. We're giving them the power. So if we choose to give them a power enough to where somebody might get harmed by it, it's not the agent's fault. It's on all of us, because we architected the system. So before we start coding, before we start thinking agents, we must also keep ethics in mind. Yeah.
So, oh, sorry, we're doing this. Okay, so as I think about what it looks like to operationalize agentic workflows, a big question that I keep coming up against is, how do you evaluate this for something that is in some sort of, XOps process?
Yeah.
And you could technically use an LLM as a judge to look at responses or read through trace logs, but I'm wondering if you have any advice as people are looking at how do we actually run this in an operationalized model?
Great question. Thank you for that. So there's a framework, crawl, walk, run. In crawling, you would test, prototype, and by testing doesn't mean test for 2 hours and then put it into production. You test it over time, and you simulate whether it's producing the results that it is supposed to do. Then you upgrade it, it's graduated progress, then you upgrade it to a large scale. You do the same thing. Maybe this time in the walk phase, your monitoring time should be twice the monitoring time that you had in crawl. And then you put it to run, which is the production phase. So it's all staged approach. It starts slow, start with intention, test enough. I cannot emphasize test enough. Fool it, make it fall. Put barriers in its way, make it trip and see if it trips. And only when you're confident, you should put it to production and mass scale.
Let's take our next virtual question.
Can you give an example of a successful agentic system you use at Cargill, or an example from a different context?
Not at Cargill. I'll give you a funny example. So I've trained an agent to keep my head straight. So I'm a mom of 2 kids. I know there's another mom of 2 little kids sitting right there. I have a work calendar, and then I have a mommy calendar. So I've trained an agent that tries to sync my calendars and tells me where I'm going and at what time, and for how long, and with who. So yeah. It's a single agent. It's a very plain vanilla agent, but it's helping me tons. And going back to your question, I would say if I were to put it in crawl, walk, and run, I would say I'm somewhere between crawl and walk phase with it, because it's made me miss a couple of birthday parties. My kids were not happy.
I was going to say you need to share that with the rest of us. Yeah. Okay. Any other questions in the room?
Okay, so my question is, let's say the workflow which you have shown, where there are summary agents and then human in the loop. Let's say, for an instance, you are removing human in the loop, and you want that workflow to be not dependent on human, and it should act as like AI is acting. So will that result would be more reliable or not?
Okay.
Like, is it a best idea to exclude that human in the loop?
Okay, so there's 2 things to your question. Is it a best idea to improve a human in the loop? No, and no with the capital N-O. Now, could you replace a human in the loop, and could you bring in another large language model for reasoning and verification? Absolutely, yes. And that is a common practice. It's not a novel idea. It's a common practice. You can bring in another LLM. So going back to that architecture that we had, I don't know if I have time to go there reasonably. Here, the 2 summary agents, could I have combined them into 1 agent and given them access to more tool calls? Yes. Could I have removed that second guy, the human in the loop that's at the bottom? Yes, I could have brought in a large language model. Again, agents are a capability. You design them, you test them, and you put them to production. Does that answer your question? Okay.
We've got time for one more question. I saw a hand up here.
Thank you. This was great talk. So this morning I just gave a talk on trustworthy AI. So I really love trustworthy AI. So with respect to your talk about agentic AI, I know we have many AI agents in play. So how do we maintain trust among these interactions, and how do we keep track of it?
So that step in the bottom, feedback logged for audit and transparency, right there. Like I said, I cannot, and she's asking a very great question. You're a senior data scientist at Boston Scientific, right? So she knows what she's talking about. Every agent, actions should be explainable. And you should be, as a human, you should be able to audit the trail of actions and decide was one action with the associated outcome optimal or not optimal. So it's very important to create these audit logs and make these audit logs accessible to your IT and governance teams. Also, it shouldn't be just one person making that decision. That's a good question. It should be graduated autonomy. So IT team comes in, audits the audit log for an agent. Then a governance team comes in and validates the findings of the IT team. So humans are going to remain in the loop, because guess what? If you give full control to agents of your lab results and diagnostic results, I don't know about you, I don't want that happening anytime soon. Yeah.
I just have one follow-up question to that. So because there are so many agents at play, and everything is connected, it's good that we are tracking audit and transparency, that feedback is logged. But what if more than one agent is down? I mean, more than one agent isn't working well because of some issue. So where is the backup?
Exactly.
In this
so
loop.
The backup is not on the slide, but at the back end, you would create the fallback modes, right? So this goes back to this slide that I was presenting, agent resilience. We want to create these fallback modes in the back end to where if the agent goes down, data dropouts, network outages, whatever the reason might be, 2 agents just dying out on us, then there should be some fallback mechanisms that we have put in place so that the system recovers gracefully and at least continues partial operations during and after disruption.
It answers. Thank you.
All right, let's give Amber one more time a round of applause. Thank you.
Thanks, guys.